Hello friends, hope you are doing well. So this is our first session on cloud learning series. This will be focused on cloud basics for beginners who have just started learning and understanding about the cloud. Okay. So whenever we say cloud journey for an application or an enterprise, we call it a journey, right? So there is a source and there is a target, destination. Source is on-premise data center where applications are currently hosted, and target is the cloud. So let's see and understand more about it. Yeah, so this picture is trying to showcase the on-premise data center. Here you can see this is a facility. It looks like a factory which has everything at one facility. Here there is a production plant, there is a material warehouse, there is a admin block, and there is a data center block. This data center block may have one or two rooms which are having the racks containing the machines of servers hosting the applications. These machines or these data centers are called on premise because they are located on the facilities owned by the enterprise. That's why this is the premises of the enterprise where the data center is located. That's why it is called on premise. Now, what are the problems or challenges with on-premise data centers? Till now, we have been doing good, but considering the development of cloud, now the challenges that we see is first, we need to have expertise who can create and maintain data center. We need to first invest our capital on purchasing the hardware. How much is the usage? What is the benefit? We will be coming to know at a later point in time, but initially a significant capital expenditure is required when setting up the data center. Since technology is continuously changing, we also need to continuously maintain and upgrade that hardware setup. We need to regularly update it, correct, to keep up with the latest technology trends. So these are some of the drawbacks where enterprises find it challenging to maintain the data centers on premises, and that is where the benefit of cloud comes in. So let's see how cloud is different from the on premise data centers, right? Okay. Now, we saw in the previous slide that the data center was hosted on the premises of myfactory.xyz. Now, we can see that this mycloud.com, which is a cloud provider company, it has larger facilities. They are only containing the data centers. They have large pool of resources, large pool of CPUs, large pool of storage, memory, respective network lines, high speed bandwidth lines, and latest technologies available for storage and warehousing, etc. They also create facilities which are redundant, so that in case of disasters or a hardware failure, they can fail over to a different facility which is located nearby, right? These facilities are called redundant zones, right? They are generally located very nearby, but there can be a physical distance between them up to 100 kilometers also. That may be required for some regions where they which are very prone to disasters, and keeping a safe distance of above 50 kilometer reduces the blast radius. In case one of the data center fails, other can still keep running, and while people work on the team works on bringing back the other data center up. So now this cloud provider company has the sole responsibility of managing these data center, and now they offer these data centers in a multi-tenancy OPEX model. So we saw CAPEX during the on premises, and OPEX is coming when we go to cloud. So what is OPEX? OpEx is we don't expend our capital in setting up hardwares for our data center. So that is taken care by the cloud. We just rent it out when we need it. So we only incur the operational expenditure, and that is called OpEx. This helps faster innovation cycles. Whenever latest technology comes, we can quickly use those resources, quickly test it out and see whether that is beneficial to us or not, and accordingly make use of it. If we were still in on-premise, we have to first buy that hardware, and then we come to know that it is of no use, and then we have to kind of see how to dispose it or decommission it, right? That's a lengthy and non-profitable process. Here it's very fast. In moments we can create the resources on cloud, test it out and decommission it, right? Here you can see it's multi-tenancy model. So an individual, any other enterprise, say a bank or any manufacturing unit, they all can have their resources deployed on a same physical building, same physical facility. Even their resources or applications may be running on the same rack. There are possibilities that enterprises may ask for physical separation of their hardware, so they can have separate racks which are not having any resource for any other enterprise or user. But in general, for smaller enterprises or user, it is the case that they may be even sharing the resources at a level of CPUs. So one of the CPU has half of the capacity being used by some other tenant, half of the capacity is being used by some other application, right? So this kind of scenario is also possible with with cloud provider or public cloud providers, which brings in more optimized usage of resources as well, and at the same time a freeness to use and decommission at will, pay as you go model, right? So that's what the major benefit of cloud is, that the responsibility of maintaining hardware, putting capital expenditure, upgrading it goes to third party, and we just rent it out whenever we need it. Now let's see a little bit more technicalities. You may be wondering that how this is different from this, because when managing these resources or allocating half of CPU to one and half CPU to a different user, it's obvious that it's not a normal model of having machines and servers that we have been seeing till now, right? So it's slightly different. So let's see that same thing. Okay, here you can see pool of hardware. One new component that is coming here is hypervisor. It has been there for long. People who are familiar with virtual machines, people who are familiar with Clouder, they would be knowing it for sure. But for people who are new, and for them this course is targeting about, so this hypervisor is responsible for managing this pool of resources. So these CPUs, memories, storage, disk, network interface cards, motherboards, all are managed by hypervisor, and it creates virtualization on top of it, right? So it's not one to one relationship between this and any application. It could be one to many. So one application may use more than one CPUs, and one CPU may be serving more than one application as well, right? So those kind of scenarios are taken care by hypervisor and further by Kubernetes, that we will see in the next slide. So there is another component that is called cloud controller. So this layer is above hypervisor, which provides APIs that can be called by various resources to create cloud resources. So cloud controller APIs are called by various endpoints, like they provide web console that can run on browser. You can manage your entire cloud infrastructure via web without anything to code, just by click, right? You can create resources, you can delete resources, you can manage resources, you can monitor resources. You can use CLI, right? Command line interface. every cloud provider provides their command line interface. For more technical people who are more secure, want more secure communication and all, they can use CLIs. Infrastructure as code to maintain uniformity of the infrastructure and have a view that the state of the server and configuration of the server is same as it is intended to be. You can opt for using infrastructure as a code like Terraform, right, where you define the resources in a declarative way and the resources are getting created by a pipeline, and they also follow the same track of using calling cloud controller API, and further that API connects with hypervisor to provision those resources. You can create custom apps, or even various apps are there which call these APIs to do the same thing. So there are various ways to provision the resources now, and they all are managed by this main component, that is hypervisor, responsible for virtualization of the hardware. Okay. Now let's see how those resources get organized. So once the request has been sent, hypervisor will organize these CPUs memories into virtual machines, right? These becomes the node. So this is the basic unit which is available. So we in cloud, we have different kind of offerings, right? Infrastructure as a service, platform as a service, right? Software as a service. So VMs are basic unit for infrastructure as a service. So they will provide you a raw machine which will have the required number of CPUs, required memory and storage, and then you can do whatever you want with that machine to deploy the application directly on virtual machine, or create a Kubernetes cluster combining multiple machines, then deploy the apps on Kubernetes, or deploy database on virtual machines, or create serverless offerings. The cloud providers also provide serverless offerings which are based on, sometimes based on virtual machines and sometimes also based on the Kubernetes, right? So serverless offerings are where you don't have to bother about what is the backend. You just work on deploying your application. There are some limitations with serverless, that you can deploy only specific kind of applications, but you can use these offerings wherever you require a faster delivery and low control over the infrastructure configuration. And so this is how resources are organized at a high level. We will deep dive into it when we go into next sessions, but for a high level understanding, this is how the resources on the cloud are organized, right? Okay, now let's see some of the key players in this cloud provider service. So three major players worldwide are Google, Microsoft and Amazon. Amazon's offering AWS has the major market share in the cloud offering. Microsoft's offering Azure cloud, which has the second largest market share, and Google's cloud is called GCP, Google Cloud Platform. It is the third largest market. It has third largest market share and moving up very fast, right? So let's see, as we saw that every cloud provider provides web-based consoles to manage their resources. So this is just to give you a glimpse of those cloud providers. So first let's start with Google Cloud. So this is the portal of Google Cloud. Once you have subscription and you log into it, you can see this web console where you can see your project and your resources are organized within a project. Okay, so you can see cloud storage, BigQuery, VPC network, Kubernetes, compute, billing. So anything, as I said, you can manage via web console. Apart from web console, Google provides its CLI. Google's CLI is called G Cloud. It's to log into a CLI, you need to run first command as gcloud auth login. It will open you another page on the browser where you can log in with your Google Cloud credentials, or it may give you a link where you can log in and it will give you back a key which you can enter to access on the CLI, right? Then third option to manage Google Cloud resources is via infrastructure as a code. Google provides its own native deployment manager for managing Google Cloud resources, where you can define the Google Cloud resources in a YAML format in a declarative way, and deployment manager will take care of creating those resources, as we saw in the previous screen about virtual machine, database, serverless, Kubernetes, anything. Deployment manager will take care of it. Second option is using Terraform, and here if you are writing Terraform script for Google Cloud, you have to use provider as Google. Okay, so these are three options that you can use, either console or CLI or infrastructure as code for Google Cloud. Let's see similar options available for Azure. So this is the look and feel of Azure Cloud. Here once you log in, you will see something like this, where you have Microsoft Azure. You can also take subscription, free subscription, which gives you initial $200 credit for some time, 2 to 3 months, where you can test creation of resources, do some POCs and validate whether the solution is suitable for you or not. Right. Now you can see Copilot, which is a Gen AI based assistant, which you can use to take help on various capabilities of Azure Cloud. And here also, as like Google, you have options to create various resources on Azure portal, Azure Cloud, using the web console. Okay, now the CLI option, as we saw for Google Cloud, the CLI option for Azure is AZ, right? AZ is the CLI for Azure. You need to download Azure CLI, and the first command to log in you need to run is AZ login. You need to enter your credentials, and you can manage your Azure resources via command line interface. Okay. Now similar to Google Cloud, you have option for infrastructure as code. So ARM templates, ARM, right? Azure Resource Manager templates are Azure native option for creating Azure resources, which uses JSON format for declarative defining your Azure resources. And Terraform is obviously available, but for using Terraform with Azure, you need to define the Azure provider as Azure, Terraform provider as Azure, and then you can use Terraform to create resources on Azure Cloud. Now last but not the least, with the largest market share, AWS, Amazon Web Services. And once you log into AWS, you can see this kind of web console, where you can see the location that you are logged in, the most recent resources that you want to you have been using, how many applications are running. So similarly, similar to Azure and Google Cloud, you can manage your resources entirely through this web console without needing for any other resource. But if you want, you have option to use CLI. The CLI is called AWS. The first command you can use AWS login. And infrastructure as code, AWS native option for IaaC is Cloud Formation. Using this is again a declarative way of defining your resources for AWS. And Terraform, which is available to all. This for AWS, you need to use Terraform provider as AWS, right? So this was just a glimpse. What we saw was on-premise, what is on-premise, what is cloud, how at a high level how the cloud resources are organized, and three major cloud providers, public cloud providers, which are having the largest market share as of today in the industry. So hope you have got some insights. Please look out for more sessions. We will be deep diving on a specific cloud provider services, resource creation and maintenance in the upcoming session. Till then, take care. Have a good time. Bye bye.